All right. So good evening, everyone. You are welcome to another segment of our class. So we submit the work. You are expected to select option space options. If you take the answer already in the questions, no accepted. Just options. Okay? Just options. Pass it forward. Pass it forward, please. Okay. Pass it forward. Are you still answering? Make it answer. So who will read the first question for us? Who will read the first question for us? Sanusi, read the first question for us.
Are there obtained by the nation of A, tertiary alkanols, B, primary alkanols, C, alkanoic acid, D, secondary alkanols.
So, in that case, which one is the correct answer based on what you have chose? This is your phone. You have this. Where is your end? You have this. Then you have this one. Black. Then you. This is yours. All right. This is yours. No. All right. So we are going to assess the questions one by one. As he has read, alkanones are generally obtained by the oxidation of what? Is it tertiary alkanols, primary alkanols, alkanoic acids, or secondary alkanols? Now, in this case, what is even oxidation? What is oxidation? Yes, who can tell us what oxidation is? What do you understand by the word oxidation? Oxidation. It means what? Huh? Oxidation means what? The word oxidation means what? Huh? From your elementary knowledge, when we say oxidation in chemistry, what does that mean? Huh? You have no idea? You, no idea of what oxidation is? You, no idea? You, no idea? I'm not even looking. You, no idea? And you, no idea? Okay. When we say oxidation, it simply means addition of oxygen to a substance. Put together. Oxidation means what? Addition of what? Oxygen to a substance. So, when we say oxidation, its simple form is equal to addition of what? Addition of oxygen. Now, in this very particular question, where we have alkanones, in this case, alkanones are organic compounds which are having the functional group of, you have R, a carbon, double bonded oxygen, and another word, R. Now, R can be your alkyl group, CH3. All together. So, in this case, from what we are seeing here, this is the functional group for alkanones, which are known as ketone. Are we clear? So another name for alkanone is ketone. Now, if you add oxygen to this, what will happen? That is the question. What are we going to get? Option A says tertiary alkanones. We are referring to alcohols here. Primary alcohols, which are also known as alkanols also. Then we also have alkanoic acid or secondary alkanols. Put together. So which one will best give us the answer? Which option will give us best? When you add oxygen to that ketonic group, what are we going to have? We are going to have what? Secondary alkanols. Do we agree with him? Do we agree with him? Huh? Do we agree with him? You are not answering. What is the option you said? Option D. Option D. That is the correct answer. Secondary alkanols. Are we together? So, this is the correct answer. How is this the correct answer? It is carrying 2R. So in this case, when you have two alkyl groups, you are going to have what? A secondary. Are we together? So when this oxygen comes, you are going to have secondary alkanol. Alkanols have the what? This is what you are going to have. R. Okay, then you have C. OH will be here. And then you have what? Another R. Okay? So this is your secondary alkanol. When you add oxygen to this. Are we together, class? Yes. All right. So the next question says what? A mixture of iodine and what? And sulfur crystals can be separated by treating with what? You know what iodine is, isn't it? Remember, iodine is one of the substances that can easily what? Sublime. Isn't it? What do you mean by sublimation? If iodine can sublime, it means it can undergo what? Sublimation. So what is sublimation? Changing of what? A matter in solid form into what? Gas form. Is that not so? That is sublimation. So iodine and sulfur crystals, you can see both of them, they are mixed together. One of them, like iodine, can sublime. Sulfur crystals cannot sublime. So when you have the mixture of iodine and sulfur crystals, then we said they can be separated by treating with what? If there is no sublimation that will take place, definitely you are going to treat them using a particular solvent. Now the first option says, are we going to use methanol to filter off iodine, thereby leaving the sulfur crystals behind? Option B says, are you going to use carbon 4 sulfide? Are we together to filter off iodine? Or are we going to use ethanoic acid to filter off sulfur? Or are we going to use water to filter off sulfur? So which one is our correct answer now? Which option are we going for? Yes? This very particular question is under separation technique. Is that not so? So in that case, what are we going to have? Yes? What is our answer? We are going to use carbon phosphide to filter off what? Iodine. Are we together? Why is it so? Carbon phosphide, as it is an inorganic solvent. Are we together? Now, when you pour the carbon phosphide solvent into the mixture, iodine will get what? Will get dissolved. Sulfur powder or crystal will not dissolve. Are we together? So, by the time iodine dissolves, what happened? What happens? The sulfur will remain as what? Residue. It will remain undissolved in the carbon phosphide. So in that case, what will happen is you use your normal filtration process. You get your what? Filter paper. Is that not so? You pour the sulfur and the iodine that is dissolved in the carbon phosphide. Then the iodine will what? Pass through in form of what? Filtrate, isn't it? Thereby leaving the sulfur crystal behind. Are we together, class? So that is that. So the correct answer now is what? Is B. Are we together? All right. Question 3. Question 3 says, sieving is a technique. Sieving is a what? Technique used to separate mixtures containing solid particles of A. Are we talking of large sizes? B. Small sizes? Are we together? C. Different sizes? D. The same sizes? So which one is the correct answer? Somebody is saying option B. C. Different sizes. Is that not so? Yes, because if you observe the mixture you are having, they are solids, in which the other one differs from the other one based on its particle size. Remember the last class we had under separation technique. For example, if you want to separate sand, or let's say gravel, from rice particles, the size of rice particles and the size of the smaller stones that are present there as mixture, they're not the same. I hope you understand what we are saying. So in this case, we cannot say small sizes. Rather, we refer to different sizes. Is that okay? As our correct option. Now, question 4. The repeated unit in natural rubber is, this one is under polymer chemistry. Is that okay? Now, you are expected to know some of the basics in polymer chemistry, which we are going to be explaining and expatiating more on them. Is that okay? Now, when we say repeated units, we are talking of monomers. We're talking of what? Monomers. Monomers are smaller molecules that come together to form giant molecules. And those giant molecules formed by monomers are referred to as polymers. Okay? So, when you have monomers, monomer A plus monomer B, okay, plus monomer B, this will give you what? A polymer. It will give us what? A polymer. Is that understood? Now, in this case, Natural rubber is a polymer. Natural rubber is a what? A polymer. So the question is now asking us, which of these options is part of a monomer that forms the polymer natural rubber? Option A says neoprene. Option B, alkyne. Option C, N-propene. And option D, isopropene. So which one is the correct option there, class? Huh? Which one is our correct option? Huh? Which one? No idea? No idea. If we say neoprene, this is completely out of points. Okay? Because neoprene, as it is, do not have that capacity in terms of unsaturation to link other monomers together to form the polymer, which is the natural rubber. So the degree of unsaturation in neoprene is less. When we say unsaturation, we are talking of what? Double bond. Are we together, class? Between the carbon atoms. Neoprene is having no branches in addition to that. Okay? So there are no branches. So neoprene lacks that. Alkyne. When you say alkyne, we are talking of what? A carbon that is strictly bonded to another carbon. For example, you can have a carbon strictly bonded in this form. This is an alkene or alkyne, as the case may be. Now, in this very particular functional group, there is still no possibility of other monomers to link up. So, okay, due to the high degree of unsaturation. Are we there? So, for a monomer to be qualified to be a unit, which is a monomer, in order to connect with other monomers, it must have an optimal degree of unsaturation. Are we together? Optimal degree of what? Unsaturation. So, alkyne don't have that. So in that case, it cannot serve as a repeated unit. Then when you say N-propene, we are talking of normal propene. Normal what? Propene. Propene has how many carbon atoms? 3. When you say methane, 1 carbon atom. Ethane, 2 carbon atoms. Propane, 3. Isn't it? Now, if it is propene, you are going to have the double bond attached to either one of these carbon atoms within the chain, whereby you are going to have this side completed, whereby you have hydrogen atoms attached to this very particular carbon here. Then you end up having another hydrogen here, then you have another hydrogen here, you have another hydrogen here. So this is N-propene. So there will be no what? Link whereby it can repeat itself for what? Monomeric entities to come together to form the polymer. This is part of organic chemistry, which we are going to also expatiate. Are we together? So the correct answer is isoprene. Is that understood? Yes. Any confusion? Any confusion? Yes, any confusion? No confusion, right? Okay. The last question. We said that a common characteristic of copper and silver, okay, in their usage as coinage metals. You know coinage metals? Metals they use in making coins. You know, before the stoppage of the use of those, the federal government did not really stop the use of coin. People neglected it seriously. Because by the time you take point to go and buy something today, not only will accept it. But the federal government did not ban the use of coin. Yes, if you go to other banks, it's the same points. So they use these three important metals for the production of our coins: copper and silver. Okay, so in that case, their usage in the production of coins, are we together? Is that A, they are easily oxidized. Is it because they are easily oxidized? That is why we use them for the production of coins. That is what the question is saying. Easily oxidized here simply means oxygen can easily be what? Added to them, thereby to form oxides. Is that the reason? Option B, have high metallic luster. You know what metallic luster is? One of the most important properties of metals is metallic luster, meaning they shine when polished. That is what metallic luster stands for. They reflect light. They shine due to the what? Their surface being polished. Are we together? Then, is it because of that they use them to make coins? That is what the question is saying. Now, they have the ability not to be easily oxidized. Is that the reason why they are not used as coin? Then finally, they are not easily reduced. Yes. So which one is our option now? Which one is the correct answer? I'm asking right now. Because as soon as we finish this, I will mark, see what you have, and then I will give you a assignment to go and solve more questions, if time permits us. Yes? What is the answer? We are waiting. Yes? What is the time say? It's like this, my wristwatch is having problem. This is 5:22. Or is it 25? What's time there? Nobody. You don't work with time. Yes? What is our answer? If you observe, all of them are what? They are metals. So metals undergo what kind of reaction? Metals undergo oxidation, isn't it? Easily. If the metal is very reactive, it can easily undergo what? Oxidation. Is that not so? But these metals are not very reactive. Which means, in this case, they are what? Not easily oxidized. That is the answer, which is option 1. Option C. So, ladies and gentlemen, we have come to the end of this very particular class. Where's my red pen? Yes, it's time to award scores. How many? 1/5. It's okay. Somebody can still do better. Okay? Yes. What did this candidate score? 2/5. There is still time to do better. Yes. These candidates. Yes. How many? 2. Okay. How many? This candidate score. 2. You can do better. Okay. Yes. How many? 2. So you write down the corrections, please, and then you go home and study them. Yes. 2. It's okay. All right. So take down these assignments to be submitted in the next class. Okay. All right. So I'll be dictating a bit. So extend your books. Give them their books back. So take down these questions. Assignments. Are we there now? Question 1 under the assignments. Hydration of ions. Hydration of ions in solution. Hydration of ions in solution. Hydration of ions in solution. Hydration of ions in solution is associated with is associated with A, reduction of heat, B, liberation of heat, liberation, Liberation, liberation of what? Of heat. Liberation of heat. Are we there? That is giving out of heat to the surrounding. That's what means liberation of heat. Option C, conduction of heat. Conduction of heat. Conduction of heat. Are we there? Then option D, absorption of heat. Absorption of what? Heat. Absorption of heat. Are we there? Then option D, absorption of heat. Absorption of what? Heat. Absorption of heat. Question 2. The knowledge of half-life can be used to the knowledge of half-life. Half-life, yes, HALF. The knowledge of half-life. The knowledge of half-life. Half-life can be used to A, detect an element. A, detect an element. B, no, right. A, detect an element. I want to see the right. A, detect an element. B, irradiate. Irradiate. I-R-R-A-D-I-A-T-E. Irradiate. Irradiate an element. That is option B. Option C. Irradiate. I-R-R-A-D-I-A-T-E. Irradiate. Okay? Then option C. Create an element. Irradiate an element. Option C. Create an element. Are we there? Then option D. Split an element. Split an element. That is option D. Then the next question. A form of carbon. A form of carbon. A form. A form. F-O-R-M. A form of carbon used. A form of carbon used for absorbing poisonous gases. For absorbing poisonous gases. Are we there? And purification of noble gases. And purification of noble gases. And purification of noble gases is option A, carbon black. Option A, carbon black. Carbon black. Carbon black. Option B, wood charcoal. Wood charcoal. Are we together? Wood charcoal. Option C,